Hello guys. All right, so I'm going to do an example right here for a two sample Z interval for P1 minus P2. I'm sorry, it's not a Z interval, my fault. A two sample Z test for P1 minus P2. We're doing a test, right, which is what we did in class. I will also do an interconfidence interval also, but for right now, we're going to do a test right here. So again, we're doing a two sample Z test for P1 minus P2 is what we're doing right now. Okay. No problem. So let's read the problem. In an effort to reduce healthcare costs, a large company sponsored a study to help employees stop smoking. Sorry. Half of the subjects were randomly assigned to receive $1,000 for quitting smoking. Okay, while the other half were simply encouraged to use traditional methods to stop smoking. None of the 300 total volunteers knew of the financial incentive when they first signed up. At the end of 1 year, 12% of those in the financial rewards group had quit smoking, where 8% in the traditional group had quit smoking. Does the results of the study give convincing evidence that a financial incentive helps employees like these quit smoking? Okay, so we're going to do a four-step process, but before I do that, I'm just going to write some notes right here. So we know, first of all, the first P hat, I'm going to say right here, it looks like 12% of those in the financial rewards group. So I'm going to call that P hat of F, subscript F. And it looks like they had 12% success in quitting smoking, right? Or they got a 12% of the people in that group quit smoking. And in the other group right here, this is just given a traditional group. They were just told traditional methods to quit smoking. They had an 8% of the people in their group ended up quitting. Okay, so that's important right there. And it looks like my N value for both groups, each of them are 150. So it means that N sub F is 150 and N sub T is also 150. Now, how did I get 150? It says that there was a total of 300 volunteers right here. It says half were assigned to receive $1,000. The other half were encouraged to use traditional methods. So that's how I knew they're both 150, okay? All right, no problem. So let's go and first of all do the state portion, right? So state, you can just put S. So the null is that P1 minus P2 equals 0, okay? Now I'm going to change it from 1 to 2 because I made a subscript right here. Let me switch that. So I called it what? I said that P sub F is the financial group, P sub T is the traditional group, right? So I'm just going to change that. And it's up to you. If you wanted to use 1 and 2, that is just fine. But I find it easier to use subscript so I know what I'm talking about. And I'm going to change this to G. T, I'm sorry. F is financial reward, T is traditional. And I'll change this right here also. That's finance and that's traditional, no problem. All right, there we go, okay? Now, why is it that I made the alternative greater than 0? Because right here, I want the financial group, we're trying to prove right here, as you see, it says right here, does this give convincing evidence that financial incentive helps employees like these quit smoking? So if it helps, that means the proportion who quit smoking who got the financial reward is greater than the proportion that got traditional methods. So that's going to be greater than 0 is what I put right here. And I define my parameters, all right, where P of F is the true proportion of employees like these who quit smoking after getting a financial reward to quit. And P of T is the true proportion of employees like these who quit smoking after being encouraged to use traditional methods to quit. And it did not give us an alpha. Make sure you always put right here, whatever. If it doesn't give you one, then regardless, you always need to put alpha. If it doesn't give you one, you need to put alpha equals 0.05. Okay. So all good so far for the state portion. Now we're going to go to plan, okay? Random. Now in this case, right, you've seen some of these problems are actually random assignment and they're not random sampling. Let's take a look at what this was. It looks like this right here is half the subjects were randomly assigned to receive $1,000. The other half were encouraged to use. So they're all right here. These subjects were all randomly assigned, it looks like right here. So right here is a random assignment. Okay. let's say random assignment of subjects. If you want to go ahead and put the n value right here, that might be useful for, maybe for when doing the large counts right here. So the n value, we had n of f is 150, n of t is also 150. Okay, but all you have to put is random assignment of subjects. 10%, of course, that's not necessary because we didn't do random sample. So just say not a random sample. All right, large counts right here. Remember, the successes have to be greater than or equal to 10, and the failures have to be greater than or equal to 10 of both groups. All right, so let's go back right here. I'm just going to get my information that's right here so I can copy and paste it over, and I can use that for the large counts right here. There we go. I just want to put this here. That's why it's good to take notes right here while you're actually looking at the problem, so I can easily figure out the large counts right here. So no problem. Now we don't have a fraction for the sample, so unfortunately we just have to go and say right here, we're just going to say what? We're going to say 150 times 0.12, and then it's 150 times 100 minus 12 is 88, right? So 0.88, and then the other one is going to be 150 times 0.08, see 0.08 right there, and 150 times 0.92, right? All right, so we end up getting right there. Sorry, I did not calculate these yet. Give me 1 second. Okay, there we go. So we end up right here with 150 times 0.12 is 18. 150 times 0.88 is 132. 150 times 0.08 is 12. And 150 times 0.92 is going to be 138. Okay, so these are both greater than or equal to 10. So we're good right there. Okay, we did all the plan section right here. All right, and remember right here, the reason we had to use the sample is because we don't know what the true proportion is, right? All we know is that the true proportion when we subtract equals 0. We don't know what the true null value, I should say, is. We don't know. We just have the sample values, all we have, okay? Now we're going to do the do. All right, so I'm going to use my calculator right here. All right, so let's go to the previous slide when I'm using my calculator. Remember what we do? We go to stat, we're going to go to tests, and we're going to go to, remember, to prop z-test. Don't use sample. That you have to have the population standard deviation. We don't have that, so we're going to use to prop z-test there. All right, let's put the first one in. So the proportion is 0.12, right? So no problem, and the n value is 150. So what I actually have to do is I have to say 150 times 0.12, which is we already have, I think for the large counts is 18. So I'm going to put 18, and the denominator I'm going to put 150. There we go. And then for the other one, it's 0.08 times 150 is what's going to be in the numerator right here for the x right here. So 0.08 times 150 is 12. And no problem. And the n value is here also 150. Okay, so hope everyone understands what I did right here. So to get this right here, this x value right here, just to reiterate what happened, usually we put it just as a fraction. We don't have that data right here, so we had to say 150 times 0.12 to get that. 150 times 0.12 we already did for the large counts condition. That is 18, so that's why I put 18 there. All right, 150 times 0.08 is 12, so that's why I put 12 right there for the second one. And they're both n values are 150. Now right here, notice it is greater than 0, so we're going to use the greater than symbol right here. So there we go. It's go down here and go right there, greater than. All right, we're ready to do it. So there we have it. So let's go, and now we have our, what we have to put. We have to put our z-score. That is 1.1547 looks like right here. You can go to either 3 or 4 decimal places, that's fine. And the p-value is 0.1241. Okay, all good. That's all you need. If you want to re-put this other stuff here, if you want to put the other the sample proportions we had, remember, put that as F and T previously. So if that helps you, go ahead. All right, but we already put it in the notes anyway. So, and all we have to have is the z-score and the p-value. And make sure you put tech. There we go. Next, we're going to go to conclude. Let's conclude this guy. All right, so we're going to say because the p-value equals, right here, so our p-value is 0.1241. And remember, you compare that to your alpha value, which is 0.05. So obviously the p-value is way larger right here. So it's because the p-value is greater than alpha equals 0.05, we will reject the null. Okay, and now we have to put the what's it called? We have to put the, say there's not convincing evidence for the alternative, but use you know, we have to go and use context. So right here, we're going to say there is not convincing evidence that the true proportion of employees like these who quit smoking when given a financial incentive is greater than those given traditional methods of quitting. Okay, something about like that. So right here, what did I say? I said because the p-value equals 1.1241 greater than alpha equals 0.05, we're going to reject the null. There is not convincing evidence that the true proportion of employees who quit smoking when given a financial incentive is greater than those given traditional methods of quitting. Okay? All right, so there we go right there. That is our full 4-part. And let's just look right here at how, let's see how if the book did anything different than I did. So what did they say? Because our p-value is greater than alpha, we said that, right? We failed to reject the null hypothesis, right? That's what I said? Yeah, I'm sorry. We will fail to reject the null. My fault. I knew I did something wrong there. My fault. Let me fix that. We fail to reject the null. Sorry, guys. It's a mistake right there. We failed to reject the null, okay? And then right here, so the next part I said correctly, right? There's not convincing evidence. All right, so right here, so they said right here, there is not convincing evidence that a financial incentive helps employees like these quit smoking. Okay, so they were even less descriptive than I was. I said there's not convincing evidence that the true proportion of employees who quit smoking when given a financial incentive is greater than those given traditional methods. Okay, so maybe I was a little too detailed right there. Anyway, all good right there. All right, so part B would just be defining the p-value. So right here, I'm sorry, interpreting rather the p-value right here. So let's go ahead and do that. So the p-value right here is 0.1230, right, is what we got. Or I'm sorry, it's 0.1241. Okay, so right here, let's go ahead and do it. And also what we need to interpret the p-value is the sample proportions is what we had right here. So let's go and put those. So that is right here, 0.12 and 0.08. So p hat as 0.12, p hat of t is 0.08. And the difference right here is 0.12 times minus 0.0 is 0.04. Okay, so we're going to say right here, remember, p-value, given that the null is true. So right here, so we're going to say right here, given that there's no difference right here in the true proportion of employees who quit smoking given a financial incentive or given traditional methods, who quit smoking, given a financial incentive, I'm just going to abbreviate, and given traditional methods, there is a 0.1241 probability of obtaining a difference of 0.04 between the two groups. And just to find what the two groups are, we're talking about right here. Well, actually, you don't even have to define the two groups right here. So we're just going to say it right here. So there is a 0.124 probability of obtaining a difference of 0.04. And I forgot to say, remember, you don't just want to say the difference. You also want to say, or remember that the alternative right here was that it was greater, right? So it's going to be that or greater, a difference of 0.04 or greater by chance. Okay, and that's good enough right there, okay? So sorry about stumbling there at the end. So given there's no difference in the true proportion of employees who quit smoking given a financial settlement and given traditional methods, there's a 0.1241 probability of obtaining a difference of 0.04 or greater by chance alone, all right, or just by chance, okay? The only thing I would have put right here, of obtaining a difference in the proportion. There we go. Okay. All right. Good enough. All right, guys. Have a good day.